Let's take a look at creating algebraic relationships by using a table. So if we have an input-output table, like so, and this input-output table goes from 1 to 5, and its output starts at 2 and then goes 5, 8, 11, and 14. We can see on the input side, this number is increasing by 1 every time. And over here on the output side, which is what we want to pay attention to, it's increasing by 3 every time. This number here is going to basically be our numerical coefficient. Okay? So when we write down the relationship, that means it's going to be 3 multiplied by the number in n, or the input in that case. So we're going to call that n. So if we take a look to see if our relationship now matches our input-output table, all we have to do is sub in our first number, which is 1, into our expression and see if it comes out with our output. So if we have 3 multiplied by 1, we're going to end up with 3. So as you can see here, our output doesn't match, and it's 1 below, okay? And often if it's 1 below or 1 above, all you need to do in order to correct this is rewrite your expression and alter it for how many above or below you need. So let's take a look and see if our numbers match now. So if we have 3 and we multiply that by 1 and then subtract 1, 3 times 1 is 3, subtract 1 is 2, so it works for the first one. Let's try it for the second number. So if n is 2, we're going to have 3 times 2 is 6, subtract 1 is 5, so it works for that number. Let's try it when n is 3, where the input is 3. So 3 times 3 is 9, minus 1 is 8, so it works for that one. And if the input is 4, we have 3 multiplied by 4, and then subtract 1. So 3 times 4 is 12, subtract 1 is 11. And our final one, when the input is 5, 3 multiplied by 5, subtract 1, so that's 15, subtract 1, and that's 14. So that works for all of the input-output numbers. So here is our expression to match this input-output table.